There is a wall in front of you, flat, white, silent. Somewhere behind it, hidden in the dark, runs a wooden beam you cannot see. You need to find it. So you press a small plastic box against the surface and slide it sideways. It beeps. It stops, and without a single nail, without a single hole, it points straight at the wood buried in the wall. The question is simple: how does it know? Behind most walls stands a frame, vertical wooden posts, called studs, spaced about every 16 inches, holding the whole room up. The drywall is just a thin skin nailed across them. To hang a shelf, or a heavy mirror, or a television, your screw needs wood to bite into. Miss the stud, and the screw grips nothing but soft, crumbling plaster. So the real question behind every scan is plain: where exactly is the wood? Open a common stud finder, and you will not find a magnet, or a tiny radar dish, or an X-ray. You find a flat metal plate pressed close to the inside of the case. This plate is one half of a capacitor, a device that stores a small amount of electric charge across a gap. The wall in front of it acts as the other half. Together, plate and wall form a sensor that quietly measures the space beyond the surface. A capacitor holds charge across a gap, and how much it can hold depends on what fills that gap. Air holds only a little. Denser material holds much more because its molecules stretch and line up with the electric field, pulling in extra charge. Engineers call this the dielectric effect. Hold that one idea because everything that follows rests on it. Change the material in front of the plate, and you change how much charge that plate can store. When you first press the device flat and hold the button, it takes a reading. Just drywall, air, and whatever lies beyond it. The circuit measures the plate's capacitance and saves that number as 0, its baseline. This is exactly why you should calibrate over an empty patch of wall. The stud finder does not actually know what a stud is. It only knows this one starting value, and then it watches patiently for that value to change. Now you slide the device sideways, slow and steady. Over plain drywall, nothing changes. Behind that thin skin is open air and light insulation, so the plate's capacitance stays near the baseline and the display stays quiet. But inside, an oscillator circuit is charging and discharging the plate over and over, thousands of times each second, timing how long every cycle takes. A longer cycle means more stored charge. The whole time, it is listening to the wall. Then the plate crosses the edge of a stud. Suddenly, there is solid wood behind the drywall, far denser than the air that was there before. That wood is a much stronger dielectric, so the plate can now hold more charge than it could a moment ago. The oscillator's cycle stretches just slightly. The circuit compares this fresh reading to the saved baseline and spots the jump. You have not touched the wood. You have felt its shadow in a field of charge. A good stud finder does not just shout at the first change it sees. As you keep sliding, the capacitance rises, then holds steady across the full width of the stud, then falls again at the far side. The device quietly marks both edges, the rising step and the falling step. The center of the wood sits exactly halfway between them. That midpoint is where your screw should go, driven straight into the thickest, strongest part of the hidden beam. All of this measuring is invisible, so the device has to tell you what it found. The instant the circuit sees the capacitance climb past a set threshold, it flips on a bright light and sounds a sharp beep. Move off the stud, the reading drops back and the signal stops. Many models light a small arrow that grows brighter as you near the center. The math stays hidden. What you actually see is simple. Here, the wood is here. Some stud finders carry a second trick entirely. Switch to metal mode, and a small coil hunts for pipes and nails using magnetism, not stored charge. A live electrical wire gives itself away too, leaking a faint alternating field the device can quietly sense. So before you drill, one careful scan can check for 3 things at once: wood to grab onto, metal to avoid, and electricity to never, ever hit. One small box, reading the wall 3 ways. This same patience is why a stud finder can be fooled. Thick or wet plaster, heavily textured surfaces, or even a fresh coat of paint can blur the baseline and throw the whole reading off. Press and hold the button after you have already moved, and the calibration begins wrong, so every result that follows is wrong. The device is not magic. It is a careful comparison, only as honest as the flat, steady wall you let it learn from first. So follow the whole chain. A flat metal plate becomes half of a capacitor, and the wall completes it. You press and calibrate, and the device saves a baseline. Slide across plain drywall, and the stored charge holds steady. Reach a stud, and the denser wood lets the plate hold more charge. The oscillator's cycle stretches, the circuit catches the jump against baseline, marks both edges, finds the center, and lights up. No nails, no holes, just a shift in charge. A flat wall, a hidden frame, and a small box that finds the wood by listening to a whisper of electric charge. Nothing is drilled until you already know. It was never quite as empty as it looked. Next time you hang something heavy, press, wait for the beep, and trust the quiet physics behind the plastic. The wall just told you its secret. This was the Cutaway.